Hi, I'm Mark with Teach Me PCB. I'm the creator of Teach Me PCB and co-facilitator of this year's course with Jesse Robinson. And I'm here to show you how to get started with your PCB layout. Are you excited? I'm excited. It's 5 a.m. over here. Woo! I'm going to do this live-ish. I don't have time to do the whole layout all at once, so I'm going to record it live, unedited, as we go through, but there will be breaks in it as I have to go off and do other, work-related tasks. So sorry about that. And it's also going to take me a little longer than it normally would because I'll be talking as we go through it. So let's get started, shall we? Go ahead and open up your favorite EDA program. It seems like most all the courses are using KiCad. I'm using DipTrace, but that's okay. You should have hopefully copied your schematic, and you're either doing 10 key or a 25 key design. So we're going to get started and, just go find your schematic and open it up. You should have all of the different schematic blocks captured by now. I have those done because, well, I made the schematic. And you also want to make sure that you don't have any errors, either electrical rule errors or errors with the hierarchy. Also, I asked you to set up your net classes. Let me make sure I did that myself. Oh, don't do this to me, DipTrace. But it likes going off screen when I have different screen resolutions. But you should set up your high-speed lines. I gave you some recommended. One wire, well, see, that's a mistake. I sure don't need an 8-inch line. So I'm glad I checked that. Okay, let's say okay. And I'm going to go ahead and create a PCB. You know something? The first thing we're going to do is just get everything spread out. We were in the spot where we're going to start arranging things by hierarchy. Again, I didn't know that that was an option. So as I go through and select each one of these, let's get them all selected there. DipTrace is quietly in the background putting all these in groups for me, which is really kind of handy. Thank you, DipTrace. I'm going to do two layouts. One 2-layer board and one 4-layer board. I'm going to pick them kind of arbitrarily. Probably I'll do, since this one's simpler, I'll do it as a 2-layer. Did I just click? Did I just ungroup those? I just ungrouped those. Whoops, let's go back to that. Route hierarchy. Single switch. There we go. That's what I want to do. Okay, did I do that to any others? Yeah, the diodes I did. Of course. Addressable RGB LED. That's what I get for talking and working at the same time. Okay. So now what you can do are things like this. Here I have diode 301 and capacitor 301. It's completely possible to route this entire thing on a single side of the PCB. And in fact, that's what I did here. If you go off to assembly and you want cheap, you can cut costs by having everything on a single side of the PCB. I hand assembled. And since we're hand assembling, the increased cost doesn't really matter that much. So I'm going to put the decoupling capacitor for the LED actually on the other side, so I can have it as close as possible. I'm also going to rotate it 45 degrees. It does it need to be that close? I don't know. It doesn't. I do know it doesn't. But it's not going to hurt. I'm also going to add some vias, low resolution on the one that I'm using. So I'm going to place a couple static vias. The vias that I'm using aren't anything special. And in fact, we can set up the default style before we get going into this. If the drill isn't perfectly centered and it shifts left or right, there's still plenty of copper to drill into. Depending on if it's an inner or outer layer trace, IPC has different definitions. But that's the minimum to meet IPC Class 3. Your fabricator probably has other ideas in mind, like a minimum 5 mil annular ring. Now, as far as hole diameters, the smallest mechanical drill that your fabricators can make is 5.9 mils. We want to go up from that. I'm going to say, let's do a 12 mil hole. Now, here's something else that's interesting. Even though I'm calling out a 12 mil hole, that's not the size that they drill. They're going to over drill that. They're going to drill that, to the nearest 0.05 millimeters up from that. So, if I'm calling out a 0.3 millimeter hole, they're going to drill a, 0.35 or a 0.4, and then they're going to plate until it gets back down to that size. I don't know. That's fine. That's more than enough. I'm going to do it in English measurements, but I'll set some numbers for you guys later. I can come back and change these at any time. But what I'm looking at is like a 2812, which is bigger than it needs to be by a lot. Which is about 0.7 millimeters, 0.3 millimeters. But again, it doesn't need to be that big. And I can always change it later. VIAs stands for Vertical Interconnect Access. So where traces route horizontally along a board, VIAs route vertically. They go up and down. So I need 2 ways for a VIA. I don't really need to, but it gives me a nice low inductance. It's a good practice. Is it necessary? Not even a little bit necessary. But I'm going to do it. Anyhow, the VIA needs to you don't want that hole in the pad itself. Because if it's in the pad, what happens is the solder, once it starts entering its liquid stage, it goes down into the hole. It doesn't stay on the pad, and then you have insufficient solder. It's a big problem for assembly. Really pisses my buddy Sebastian off. And I'm going to link those vias to the appropriate pad. The idea is to minimize the loop inductance, so minimize the distance, but I still need a little bit of space between the pads and the pads and the via holes for solder mask. There is plenty of space, but the minimum web is typically around 3 mils. So those are connected there, right? You can connect them this way. I'm going to show you another way to connect things here in a second too. So now there's a couple paths. It can, the high frequency switching current can go wherever it wants to. It's going to take the path of least impedance to get back. But there's something else that you can do too. And that is something called a copper pour. That this is absolutely 100% unnecessary. So a copper pour is a big chunk of copper that you put. I'm going to say connect that to, I should have remembered what that was. That's either ground or 5 volt. I'm going to assume it's ground. And then we need to talk about these, which is why I put them down. Spoke width, 10's fine, who cares? Pouring, I'm going to remove my minimum area. Current state, pour priority. All right, so if you have multiple copper pours and they're near each other, you have to decide which ones are going to get poured if there's a conflict. DipTrace has these, going from pour priority 0 to pour priority like 99 or something. I'm going to set this as priority 4. That lets me go above or below if I need to without having to come back. All right, strong net. So this was my VDD net. Yeah. Guess I gotta go way big. I'll see if there's some setting that I need to adjust. Sometimes when you do have a ton of copper, and you'll see this with ground, when you do the ground, it takes a lot of heat to heat up that pad to melt the solder because copper is so thermally conductive, it just sucks the heat right away. It just disappears. There's nothing you can do with it. So you do these thermals, so that the heat can't leave the pad so easily. It's still going to be plenty conductive, but you can do them at 90 degrees. You can do them at 40 degrees. Where is... There we go. Properties, connectivity. Hi, Ollie. There we go. Put those in to limit the amount of heat transfer into and out of your pad. Now, that was just one side. If I'm going to bother doing this, I might as well do it on the other. And just because I am lazy, I am going to copy, I'm going to paste, I'm going to change side. And I'm going to move that into place there, and then I'm going to update. So we've got a couple issues here, similar to the issues that we had before. Just not big enough for DipTrace to want to bother worrying about it. Change properties and just go back to the regular 4-spoke 90-degree connection. Doing right now, I'm mostly doing for educational purposes. I am not doing it because this circuit warrants this much work. Anyhow, those are copper pores. Whoops, we're not using them, but I did think you might want to know about that a little bit. Just something to keep in mind. All right, now here's the interesting thing. I can take that copy, go to hierarchy, find my where's my LED, addressable LED. I've routed block 1. I can now go and copy the placement and routing, and they are all ready to go. They're done. All right, so we're just going to clean these up ever so slightly. I think you guys probably get the idea by now that these parts don't really warrant this much time, but it does illustrate some interesting things that you can do. Again, as long as there's at least 3 mils of web between the, let's go metric here, 3 mils of web between the part and the edge of the hole, you'll be fine. There's also something else you can do too, which is to change the via style to do something called tinting. So I'm going to come in here and, oh, DipTrace, why are you doing this to me? I need to see that. Okay, so there's, I want the top and bottom vias to be tinted. Let's see if we can try that again. But those things are routed. I don't want to unroute them. They're grouped. They're fine. Now, when it comes time to add these things to the switches, I can do something similar. Each switch has 3 components that need to go along with it. Might as well do them. There. 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 Okay. Perfect, perfect. Now, no, I want that. No, I want that to move. You never want the silk on the pads. The fabricators will just delete it. So you can either clean that up at the end in a pass or clean it up now in a pass. That's at your preference, and sometimes you'll end up moving it a few times. That's no big deal. There we go. There we go. And then that's going to have to go off to power whenever we actually get around to routing power. So these things are routed. There's decent enough space that I can probably get in there. Where are my other layers? How come? Oh, because it's on the back side and the contrast is turned down. Okay. So now those things are routed. You can see them back behind the switch there. I could give it a little more space there. Just shift everything over a little, just so there's plenty of room to get the iron in there. And we're routed. I'm going to do the same hierarchy trick. That is my single switch. That's routed. These aren't. Okay, now it's all routed. So all of this is in preparation for routing. You get your blocks together, you get your blocks routed if they can be, and it makes life easier for you later on, and it keeps things kind of clean for you too. Objects, rat lines. There we go. That'll make it a little easier to see. Okay, when I routed these on the brain board, the parts, I mean, these things are small, right? Sometimes you forget how small they are, but they route just fine on one side. But this time, I'm going to move them to the other. So change side. Well, you know something, let's do this. Let's do route 1, just so I don't make that mistake when I do the hierarchy. Okay, so you have to figure out what goes with what. One of the things that you can do is change the color of the traces. So, I mean, it'll highlight for you what net goes with what net, right? So this one goes down there. That one's going to go near that one. Or actually, no, that's 3-volt power. This one goes over here somewhere. We need to get back to a grid layout here. And again, I will clean up that silk. Oh, anyways, what I was saying is something like ground. You can change the color so it's easy to recognize. Go with that color, green. You can do the same thing with your 5-volt power and your 3-volt power. And we'll go bright pink. In case that helps you route things. Totally up to you. And dip trace, why are these things not lining up on the grid? There we go. So this is net res DR1, DG1, switch 1, D blue 1. And right now I'm on the back side, so I can keep those there, or if I want to, I can actually sneak them in down here. And that'll give me a tighter layout, but I don't want to be responsible for losing that silk screen. So I'm going to realign it in a stack over here on the side. The reason that the text is reversed is, you know, we are theoretically looking down through the board. So if we were able to see through the board, we would see that the text is reversed. And then done. Now we need, these guys are all part of the debounce circuit, and they give us something to route. And then that one, and then that one, and then that one, and that one. Okay. I spent way too much time on that. That's what happens when I get distracted. takes me too long to get back on things. Okay. We're going to connect grounds and everything later, but if I need to, I can always run from here into the interior there. But I do know that I've got a 3v3 problem, so I'm just going to go ahead and drop a couple of vias. One is sufficient. One is absolutely sufficient, but I want to start getting you guys in practices for higher speed designs. Now, here's another spot where, you know, we might consider doing a copper port to tie everything together. Don't know. But for now, whoops, no, I don't want that. For now, we're good. For now, those things are connected. That's good enough for now. There's my rotary encoder. All parts fit underneath except for the silk screens, which might, well, once we figure out where these are going, I might have to move those around a little more, put them in a spot that makes them make a little more sense, but that's clean enough layout. I'll take that. Rotary encoder. This is routed. This is not. Select it. Copy it. Done. Where did it go? Way over there. Dip trace, you confuse me, but I love the hierarchy features. I mean, can you imagine laying all that out twice? U201 and C201. So this is the decoupling capacitor for the light sensor. I'm just going to slide the silk screens off to the side here, just so I can get stuff in a little bit closer. This is a 3-volt net, so let's go ahead and give that a color. Red's good. Red works for me. Now, I've also was able to do something else. Or actually, I got lucky, and the program just decided to start doing it for me. And that is via tinting. So I want to make sure nothing goes into these holes. So near the pad, I can actually, there we go. So I'm just going to say that each one of those is tinted. That's fine. The basic idea is then these vias will get covered with solder mask. There won't be anything inside them, or there won't be any path for solder to go into them because they'll be covered with solder paste. They're grouped. Okay, move. Basically, I'm putting completed things on the right, incomplete things on the left. All right, we've got the USB to play with. We've got the RGB LED thing to play with. We've got the level converter to play with. I think it's time that we do a board outline, get that going into our program. And for that, I loaded up my favorite drafting tool, which is CorelDRAW, because I have a license for it. Anyhow, so now I've got to come up with something. I've already done a brain, so I'm just going to show some basics about how to create a custom shape, more so than worry about hitting any artistic goal. A lot of graphic design is adding and subtracting shapes. So if you want something, I mean, there's a lot of different ways to get to what you want, but if you want a rectangle with rounded sides, for example, you could, and actually it looks like I need to make this a little, let me make this a little smaller, and I'll make the other one a little bigger. There we go. And then, nah. But anyhow, if you wanted something that had a, you know, a round on one side and square on the other, you would take that and then weld the shapes together. Or maybe let's say you want for some reason, yeah, I don't know if I want that. I think I want 6 sides. So, you know, I want this little shape subtracted. Object shaping. Right here, do I have the right height? Let's get something useful. Let's make it 2.5. And let's do it proportionally. I don't know why we would want this, but let's say this is what we want. So you subtract them. So you either add things together or you subtract them. And ideally, you want a closed shape. And on most programs, the way that you know something is closed is you can fill it in. There's usually options to, let's see, works, no, toolbars, no, dockers then. There's usually options to round curves over if you don't want them, if you don't want sharp edges. Let's see what that looks like. Some of them were too short. Yes, I figured. Okay, I mean, we're looking at something. I don't know what it is that we're looking at, but I mean, I'm seeing it as a mailbox right now. So I'm starting to get an idea of what it is that I want to do with this. I want to make a mailbox. I don't know why I want a mailbox, but that is the shape that I want. So then you can figure out proportionally how big your switches are, and you can get an idea of, okay, well, how many can I get in here if I do it this way? Can I rotate them out of the way? You know, how many can I get? So for this, we actually need a few measurements. And if I was smart, I would have left a set of dial calipers around that I was using earlier, that I have hidden very cleverly from myself. Well, that's good. We don't have to worry about them disappearing, especially from me. Ollie, did you take the tools? Did you, buddy? Well, that is a fine how do you do. How did I even do? Oh, here we go. I did have them around. It's just getting late. So these things make it super easy to figure out how big things are. So the switch with the keycaps that I have are, and I'm set up in inches in this program, so they need to be roughly 0.715 by, let's see if I can get another measurement there. 0.7. So 0.7 by 0.715. So I can actually go over here and type that in. That's about how big these things are going to be. So I can get an idea of how big my board needs to be. Okay. Just lay out a couple of those. Let's say that's going to be my pattern. Again, I don't know why it's going to be my pattern, but this is going to be my pattern. .5 and 6. I'm going to group those. And I want to change how much I'm shifting. There are plenty of free EDA programs out there. Inkscape is an option. There I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to need room for one more. Except I don't have 12 keys, so let's delete those. And then I will get these things all centered. Whoops. There we go. And then I'm going to have a couple of rotary encoders. Okay, I don't need to know everything about this. I just need to have a basic idea of my shape, make sure that I'm going to be able to fit everything on it easily enough. And I've got that. So let's take it into the program. Most software will let you work with either DXF files or SVG, scaled vector graphics, or document exchange format. I don't know what it is. It's the Autodesk thing. So you've got to figure out what it is that you're going to actually be working with and export to a thing that is exportable. You also need to keep track of the units that your program works with. It won't always be clear to the program. So I'm going to export in inches, AutoCAD, yeah, who cares? And I'm putting it on the desktop. So now over in Mr. Dip Trace, I can bring that in and I can make sure everything fits. So, I mean, it's got a lot of options. It can do some Eagle and KiCad stuff. It can bring it in. I didn't even know that. That must either I've forgotten or it's some of that functionality's new. Anyhow, I left this on the desktop. It's my example board. Hey, yay, there we go. Really, I just want the layer. I export it in inches. I want to import in inches. I want to add it to the current design. And I don't really want to convert blocks. Shouldn't probably have left all those buttons and things in. But, I mean, it's fine. And I'm going to convert this to the board outline. Okay, let's see what happens. There we go. I have a board outline. I don't care about you people. You can all go away. But now I have something where I can start taking and placing my parts, right? And I could, if I wanted to, use those other things that we had, but I don't want to. I just wanted to show you how to do that part. I know what you're thinking, Mark. That doesn't look like a mailbox. That looks like a ghost. Ooh. I think it is. All right. Most of the choices were somewhat arbitrary, like where I decided to put the switches. You know, we decided that the LEDs go with the switches. We did the support components earlier. Rotary encoders. We did all of that earlier. The only things that we didn't do that aren't really arbitrary choices is where a few of these things go. For example, this is the IC that deals with the running the RGB LEDs. I don't want to have to route that stuff all over the board, so I'm going to keep this close to my rotary encoders. The electrostatic discharge diodes. I put these on the opposite side of the board because I want this stuff as close as reasonably possible to the inputs. So if there is an ESD discharge, it doesn't travel all over my board. It gets discharged right then and there. Okay? So that's important. We've got, I think I did one or two other things. Oh, the arrangement of the switches. So these guys are going to daisy chain from one RGB LED to the next, you know, here to here, here to here. If I would have arranged these in numeric order, you know, 1, 2, 3, 4, 5, 6, 7, 8, it would have worked, but I would have had to route stuff all over the board. And remember, what we're doing here is trying to come up with a 2-layer layout. Maybe even a 1-layer. I don't know. I am going to use some jumper wires just to show you how that's done, which will be new for me because I typically don't use those in a design. And that's pretty much it. The only other thing I can think of is this level converter. I did decide to nestle this right between the power pins, again, so I wouldn't have to route stuff all over the place. With that, I think it's about time that we get started. This is a 2-layer design. I've only got top and bottom. to work with, and if you look up in the upper right, you can see me toggling back and forth, top, bottom. Hopefully that'll give you an indication if you have trouble keeping up with what I'm doing later. All right, let's hit it. First, well, I just clicked something. First thing I'm going to do is renew from, no, no, cancel. All right. Make sure I have the latest, greatest version of the schematic. And then I want to turn on rat lines. Okay, so you can see these all indicate connections that have to be made. And as far as schematics go, it's not nearly as bad as some of the ones that I've done before. Not bad at all. So let's get some of the low-hanging fruit. Okay, route single trace. How about that? There we go. Okay, it just didn't like doing it as a differential because of the close spacing. This is where a bigger monitor would be seen. So this one goes on the right, that one goes on the left. Oh, that's nice. It doesn't really matter. It would be a nice thing to show you to do for best practice, but why didn't that transition? It's giving me an error. Okay, I'll figure that out in a second. Would have been nice to see some vias show up there. Ah, there they go. So I can nudge these things in a second. No. Silly, silly. So one of the things that we talked about in the reading is that you want to avoid large changes in impedance over long distances. But short changes in impedance over short distances aren't nearly as big a deal. The example that I used was, imagine, you're driving your car and you hit a puddle of water. Does it matter? Well, it depends very much if that puddle is, half a millimeter deep or if it's half a meter deep. You're going to have very different life experiences based on that, right? All right. How come we're not snapping to grid? Maybe I need a slightly less granular thing. Yeah, let's go down a little. Guess I could go back to metric. Wouldn't hurt. Okay. Now, what we've done, or what we should do, is actually route from the bottom of these. And I probably need to explain that in a lesson. But you're not going to be able to see if I routed top or bottom on this anyway, because, I didn't. But I need to explain why that's a better practice in the beginning. The other thing that you typically want to do whenever you do have a layer change, anytime you have vias going from one layer to another, you want to add a couple of ground return vias right next to it. We want these vias to be connected to ground, and whenever the signal changes layers, we need a path for the return current to change layers. I'm not strictly changing layers here, but I'm going to put a few return vias right next to it so that if there is any return current generated, it's got a place to go. I'll actually have a lot more vias on this by the time we're done. Hi, buddy. I know it's fun to sit on a keyboard, isn't it? I know sitting on keyboards and standing in front of the monitor is fun. Oh, I know. I know. Oh, is it time for Chester to get spa treatment? I see. All right, so I've just given a ton of options for return current to find a way back. And I'm working with a reduced invisibility environment at the moment. Oh, cats. You gotta love pets. They don't care what you're doing. If it's time for them to get some attention, they're going to get their attention. All right, so any signal that comes out of this differential pair, the positive net, is going to hopefully be able to move to the other layers on one of these 3 vias, this one on one of those 3 vias. I will say, for what we are doing, I am absolutely wasting a bunch of time right now. It just doesn't matter. You can design for connectivity with this design, and you will be just fine. But I want to show you, well, I'm not even really showing you best practice. I just want to expose you to it so that if you ever do something that is indeed higher speed, USB 3, USB 4 that they're working on right now, you're going to need this. The skills that we're trying to teach you are for hopefully a career of building things. All right, so now those things are connected. I want a solid, continuous return path for these things. So nothing really should get routed here. So on top of the board here or underneath the board here. So what are we going to do? We'll have to find a way to work our way around the board that way. One of the things that you could conceivably do, sometimes you can do edge-coupled returns where you route other traces right next to these. Sometimes you could always just route a ground trace right underneath this and pair it with it. That would absolutely work. Anything else we need to worry about? I think that's pretty much it. By the way, what I mean by that is you could... wonder if it'll let me change class. You know, Chester, it would be easier for me to work if I could see the screen. Let's call this 80 mils, see how that does. So what I mean by that, by having an uninterrupted return path, I really do mean, there you go, buddy. Okay. Should be able to work marginally faster now. What I mean by that is you do want a route that you can take where this can go all the way through. And you see, I've got an issue, and I don't know how to solve that issue just yet. I'm going to have to work on it. Tell you what I'm going to do. I am going to stop that trace for a moment and take care of the cat. I'll be right back. Oh, yeah, I also don't need necessarily an 80 mil trace. What was that the issue? That was the issue. Okay, I had some special traces. So I need to find a path that gets me from here down to here. And you see all those little red circles that it's lighting up? It's saying you can't put your traces there because something bad's going to happen. So I am going to take a path that takes me down to the board, over, and I need to get inside there somewhere. And I am going to choose to come inside here. But I need to be on the other side of the board to do it. I really wish they would have broken out these pins. That would have made life a lot easier. Now, let's modify some traces, shall we? Edit single trace of pair. Free editing of different. Yeah, let's try that. You can have impedance discontinuities in high-speed nets. As long as the impedance discontinuity is small and happens over a short distance, it does not affect your design. Not the least little bit. And again, remember what I told you, there is not much you can do to your design that's going to make it not work for you. That doesn't mean that we don't want to teach you how to do things the right way if we can, but okay, I've got an issue. I'm going to bring these over some more, hopefully. No, I want to move both of them. Come on, Dip Trace. Let's get it. Come on. Unless you're a student, in which case they'll pretty much give it to you. If you are a part of like a club team, they'll sponsor your team. They're great people, I'm telling you. Okay, I want that to join with a, I don't know why it's doing that. Why are you trying to go at an angle? Nobody wants you to go at an angle. Okay. That is what we call in the trade perfect. It's perfect enough for what I need to show you how to do. All right. These signals, especially if, say, we're using like a USB 3, they've got very fast edge rates, and they can create a lot of noise. And the way that you capture that noise is by routing a ground return path directly under on the opposite side. And space matters. So this would be a case where I would actually make a thinner than normal board. You know, normal being 1.6 millimeter or 62, 63 mil. I might do a 32 mil, which is, 0.8 millimeter. And ground, I'm going to give me that's what we want, a big fat one. I'm going to route a big fat trace just to remind myself that I want to give these traces a wide berth. Oh, but check this out. What do I do there? I can't go anymore. I'll show you what we do. You shift enter to complete trace routing with the previous. Okay. I will show you what we do. By the way, I would never actually route this trace. I would use a ground copper pour for the return path, but that structure is locked. Please select. Oh, hold on a second. It's mad because I just generated a trace out in the middle of nowhere. If I do it the other way and I start on a ground, it'll be fine. Anyhow, where was I? I don't remember what my point was. Probably wasn't a very good one. Oh, I don't usually route these. I would let a ground pour take care of it, but I want to be very clear with what I'm doing and make it look deliberate so you guys know. All right, I've got a ground return there. I've got a ground return there. They don't connect. Any signal energy that's being absorbed along this trace, it has no way to connect to that trace. It's not enough to route horizontal interconnects. You've got to do vertical interconnects. So I am going to place a couple static vias. And I am going to connect them to ground. I can move them around a little, but I am going to give that a way to get over there. No, wrong button. Route manual. Bum, bum. Oh, it doesn't like that, does it? Okay, let's go down to, say, like 25 then. We'll neck it down. Oh, does it not like that either? Let's see. How do I guess I can do that. It's ugly. But it's going to, realistically, it's going to get filled with ground anyway. So, okay, it doesn't like that. Doesn't like that. Okay. So now there's a way for any wave energy that's traveling along this trace. It's not a pretty way, but it won't matter because of something I'm going to do later, which is, and I'm going to do this at the very end, but I guess I can illustrate it to you now. Oh, it's mad at something. Is this not a board outline? Okay. Now let's try updating that. Okay, it's mad. There it goes. So even that little bit of ugliness, and I'll do that on the other side too, but that little bit of ugliness, that's a no-brainer. I'm going to connect those two things, although I think I'm going to connect it that way. It looks cooler. All right. How about these guys next? Oh, I'm still stuck on. So I want to route these things by class. So if I go in later and change the class, it's easy to do. One of the things I like doing, especially on power traces, is making sure there's no angle that is less than 90 degrees. It doesn't matter here. But here's my theory behind that, my reasoning behind it. Heat is going to travel along the board. It's going to go perpendicular to the trace as it spreads out. If you have an acute angle, you've got heat, for like here, heat coming from this top trace is going to be filling the board this way. Heat from this trace is going to heat the area this way. So if you have something less than 90 degrees, you can have a hot spot. I don't like hot spots. It would be nice if these things met at like 120 degrees, but it's not worth the effort to make that happen. And the effort is not much. All I have to do is, turn off the 45-degree snapping. There's a way to do it. I don't remember off dip trace, but I'm sure we could figure it out. It's just not worth the effort. But I do feel it's worth the effort to have them come in at angles like that, just in case. Another thing, too, is this idea of yield. Whenever a manufacturer makes a board, nothing's ever perfect. It doesn't ever come out exactly as it's shown on the diagram. Now, we've got vias that have huge annular rings. So what I'm about to show you doesn't really matter either. But let's say we've got a via that has a barely passable annular ring. Yeah, we'll add it. Let's see, that's 4, 4. That's even aggressive. Let's say we're really dialing it in, right? If this drill breaks out to the left, right, if it shifts to the left, it can cut off that trace. Here, if it goes up, if it goes down, right, if I had the same thing, it could cut and destroy that net. So one of the things that I like doing with vias are adding these things called teardrops. I'll do this at the end, but just to give you an idea of what they are. Right, they increase the amount of copper that's there, so if that drill wanders up or down, you got no problems. Now, it's my understanding that not all EDA software has that, so the other thing that you can do is add a segment, so add node, so now this is a little segment, and you can modify, let's go 30. This is huge. You can modify that little segment so that the segment's bigger around the via. Does it need to be that much bigger? I don't think so, but it doesn't hurt either. So now if the drill, and you would do this in all directions, so now if the drill wanders, add node, segment width, and what did we say, 30? Segment width 30. You get the idea, or hopefully you get the idea. So even if you can't teardrop, you can do these keyholes while you're doing it, so that if something does happen, if that drill does lose registration or it wanders off, then you're going to be okay. There'll be no direction for that drill to break out and destroy your via. In this case, there would be 3 directions where it could damage it. But you put in those keyholes and your yield goes up. Now, realistically, the most a drill that size is ever going to be off is like 3 mils. One of the reasons that your fabricators want 5 mil annular rings is so that they don't have to deal with that. They don't have to deal with breakout. So, anyhow. Where was I? So these things are connected. I connected them at right angles for heat, really no other reason, and we're not using enough current to generate any heat, any appreciable amount of heat. We could be running an amp through this. It wouldn't matter. But I do want you guys to have an idea of what the best practices are. Now, same basic idea with the yeah, I'll go down this road. I was debating whether I did. Same basic idea with the return path for the high-speed signals. You want a return path for current. At very, very high speeds, these capacitors that we're using that are called decoupling capacitors cease to function for their intended purpose because the inductance increases. So the energy is drawn from the power net. It's drawn from the area that is between the dielectric area that's between the, your VCC and your G and D. So the whole idea is to basically make, for lack of a better term, a planar capacitor. So I would run a ground return underneath this stuff as well. Now, I'm going to do that in the way of a copper pour at the end, But just something to keep in mind. This isn't necessarily a spot that you want to cross with other traces as well. So you know something, tell you what we'll do. How do we want to route this out? I'm just going to call this a copper net anyway. Copper pour for ground. Just to remind me that that's an area I generally want to stay out of. I will have that connected to other copper. Why am I seeing... Let me see current layer only. Are these shorted? These are shorted. What's going on there? Interesting, interesting. Glad I saw that. That would have caused trouble later. There we go. That's done. What else? What else? The 5 volts need to go to feed the NeoPixels. Figured that much. Where is NeoPixel input 1? It's this one, right? Or am I on the... I need to be on the bottom side on that other one. Okay, I'll move that in a second. That's continuous. Unroute this trace. All right, so I need to get from there to there. Probably the easiest way to do that is just come across and then drop a... Does that need to be that way? That doesn't need to be that way. Hold on a second. I have another idea that doesn't involve vias. Whoop. Let's not move that. Let's ungroup these. Why don't I just rotate this bad boy? Ha! Take that, dip trace. You think you can pull one over on me and now there's no crossover. Ha 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 ha. All right, so I'm planning on using a board that is 30 mil thick, and I probably got at least 50 mil between those traces. I've got more than enough space. But let me confirm that in case I'm thinking incorrectly. Yeah, there's like 50 mil between those things. Usually if you're like at a quarter of the board height, you've got plenty. And in this case, I've got such a big board, I've got a ton of room. All right, continuous path from this IC. I'm going to have copper underneath it, but I've got a continuous path from this IC all the way down to where this thing's going. I wouldn't want to just end it there. I would want to connect it to, but if you remember, once I turn on those copper pours, all of this is just going to get connected. So it will be. I don't have to draw this trace. I'm just using it to keep track of things and hopefully for you to keep track of things. I moved those segments ever so slightly, so I moved the ground return ever so slightly. But it's going to be a copper pour. I guess I can stop saying that at this point. Now, I've got a path for this guy. All of this is unnecessary. And then I'm going to have to worry about those switches later, too. Tell you what, let's do it this way. Let's come here. Oh, by class. make life easier. Okay. So I think that's the way we're going to be doing these now. Bring them over. Keep it clear of that switch circuitry. Of trickiness. Now there is. What would that look like, you ask? I am so glad you asked. I have nothing but time today. I'm going to have to drop a via and call it ground to be able to do this, because I have my net structure locked. So the only way to, I don't want to unlock the net structure, because then I could make a mistake, and I don't want to make a mistake. But see, I could put in a, whoop, no, stay there. But I can put in a trace. I like these, so they're easier to keep track of. Trace color, custom. How about whatever color that is? Off-white. Trace color, custom. Also off-white. Trace color, custom. Again, off-white. So that's where those things need to go. So it's like light blue, purple, pink. All right, so we've got to, let's unconnect these, ungroup, or ungroup, yeah, ungroup down here. Amazingly enough, routing a 2-layer board is more difficult than routing a 4-layer board. Okay, that is looking clean enough. Bring these in even closer. Not that way, though, can I? That's going to shift the whole thing. How come I can do it this way, but not on those? I don't know. Let's bring those in closer in case I have to cross them. So the reason I'm bringing these close, by the way, is that if I do have to jumper these things in a little bit, you know, put in some top wires, bottom wire, well, they'd be bottom wires. But if I have to do that, the closer they are, the easier it's going to be for me to do it. I can run shorter traces, or shorter jumper wires, that is. Using the resistor as a jumper. I know, I'm crazy. Could just run it back over here. Don't see why not. just jumper it over the ground. Do-do-do-do. Do-do-do-do. Well, no, that's no good. Many of you are out there saying, but Mark, what if I don't want to do all this? You don't have to. It'll work just fine. So Mark, why are you doing all this? It's been a while since I laid out a board. I mean, I did lay out my brain board, but I did that so ridiculously fast. I didn't even give a concern to signal integrity. I did a 4-layer board. I routed traces every which way just to make it look weird looking. There's very little that I could teach you about circuit design from that board, other than multiple examples of what not to do. Okay. So I was wondering. Oh well. Okay. So now let's put in my little keep out reminder, because obviously I am getting tired. There is not a whole lot of reason to spend this much time on the routing, other than I am doing it for educational purposes. But if it wasn't for those educational purposes, I guarantee you I didn't spend this much time on the brain board. I doubt Jesse spent that much time on his skeleton board. I have done boards that take, a data route. This is not, or should not be, one of them. Maybe 2 hours start to finish, and I think I've just been 2 hours in this session. The return on your investment for all that I'm doing right now is, it just doesn't make sense unless you like doing it, or unless, like in my instance here, unless you're having fun doing it. So what we've done is create this little weird looking fence that will give a path for this to take back. Okay, that makes me feel better. Not a lot, but a little. What's next? Is it break time? It's getting close to break time. I think each one of these has been about I don't think I'm going to have any interference. Well, there will be some spots. Wonder if I can just slide that down. And I might need to pull these down a little first. But anyways, the plan then is to bring these to the top near the impedance, but not too close, and then just start jumping stuff just to get this done. Now, I am still going to be careful about which side I jump on, because I want to make sure there is a return path. But they could cross over. So I might do my little color game again, just to get an idea of how to visualize where everything's going to go. And this one's going to go backwards. I'm going to jump over. Ooh, we got an issue there. I can eliminate it. So the issue is I'm going to have this thing go far to the left, but I've got this trace here. And that darn trace is going to interrupt the ground pour. I can't go on the other side where there will be a ground because the pico is going to be there. So I am just going to, let's see, what am I, why are there two down there? Did that eliminate it? Okay, that's good. Otherwise, that would have given me a design error later on. Add node. Segment that to the other side. And add node. Segment layer to the other side. Okay, so I'm just giving myself some additional room down here on the bottom. Add node, segment layer, top. So it should be easier to route things. Pretty sure I can do the same thing over here. Let me get rid of this for a moment. Let's unroute that segment for a minute. Looks like I can put these things on the top unroute segment. Yeah, you'll be fine. I promise you. Get rid of that jumper wire for a moment. Trace layer top. Get that via out. No! Get that via out. Here's the bottom layer again. Top layer. Move this to the top. Trace layer. Where is trace layer? Okay. We're moving faster now. Still need to get that over and through, but I can do that in this little area here. No reason that that needs to go at a 90 degree. Let it go at a 45 or a whatever degree. That's a problem, of course, but okay, now I can bring this guy up. Okay, with the exception of that little bit of weirdness, we're golden. What's next? What's next? Anything down here on the bottom that can go up to the top is going up to the top. Delete that for the minute. Trace layer top. Trace layer top. Have to deal with some V's in a little bit that have gotten out of control. clean stuff up. Add node. I don't know why it likes doing that to me, but whatever. There is nothing special or magical about about 45s and 90s in design. It's just those are the easiest ones for the early softwares to draw. If you look at old boards that were hand routed, there's curves and all sorts of wonderful randomness. Okay. That, I don't see any reason that needs to be down there. Okay. What was I even doing yesterday? I think I was too far in my own head. Oh, no. Don't be like that. Is there a tiny little segment that... Yeah, there is. Segment layer top. No. Okay, here. We'll do trace layer top. That'll make you happy. There we go. Remember, never any vias in pads and never any vias near pads. Or my friend Sebastian and Greg will scream at you. Well, not like at your face or anything. Totally be behind your back. Okay. Only thing I don't like about these wires is they look identical to rat lines. I wonder if there's a way to change that. Maybe if I could see the rest of the screen. Oh boy, I tell you, yeah. I can't tell. I can't see the whole screen. All right. These things are going all over the place. So these four need to go up. Let's get some colors going and we'll see what they need to do. Well, this one just goes straight to the right. That's easy. I'll color it anyway. Where's colors? Trace color. Off-white. Trace color. Ooh, off-white. Trace color. Let's go off-white. And trace color. Off-white. Oh man, I love picking trace colors. Can I just delete that? There we go. Delete that. I might need a little more room to route, so I'll give that a little more space. I'm going to move it later, but actually just be that much easier if I just put it up here. Trace. Bottom jumper. So I mean, with jumpers, it's kind of like having a whole nother layer to route on, except it adds an assembly step. You know, now you've got to have somebody sit there and make these wires and put them in and solder them. So you might be saving a penny on fabrication and spending $1 on assembly. Okay, so where are these things going? That little one needs to cross under. Come on, dip trace, get it together. Like, who would ever want that? I don't know. Why would you think that's an option? I don't know. Take that one there. Take that one there. Now, do I need check, and it's going to tell me that I made some boo-boos. So we haven't really talked about how to set up design rules yet, but they're set up. It's telling me all of the places that there might potentially be a problem. So like, for example, it's telling me that on my pad here that I've got 7.88 mils of space between these two pads, of copper clearance between the pads. Now, if I go over to my fabrication shop, like Royal, we can do 3 mil on 0.5 ounce copper, no problem. Even the offshore vendors can do, you know, usually 5 mil before they start looking at an upcharge. So is this a problem? Well, according to the computer it is, but based on the rules that I have set up. But is it really a problem? It's not. This is probably going to be the ESD diode. Let's see. Oh, nope, it's right here. Okay, so it's telling me that I can get a little more distance in there, and everybody will be friends. No, go. Dip trace, what are you doing to me? Dip trace. It's not letting me edit it. Let's edit a single trace, maybe? Huh. Seriously. I don't want anybody looking at the bottom of this board that I'm never going to manufacture and judging me. Okay. Check design rules. I'm going to have to let that one go. 17.44, and the rule was 18. And if I nudge this up a little and nudge that down a little, then when I update it again, I've got copper on either side, and I'm a much happier camper. But like in a spot like this, remember that the wire would have to go on the top of the board so that there is copper between the wire and the USB. And initially just start dropping these things every 100 mils or so. Now, what this is doing is stitching the top layer of copper to the bottom layer of copper. So when I turn this stuff back on, these will function essentially as a solid piece of copper from an electrical standpoint. Now, really what I should be doing is, you know, figuring out the rise times and fall times of my signals, which I haven't done because they're not close enough for me to really give them much consideration. And figure out what 1/10 wavelength is and space those at space these ground vias at 1/10 wavelength. So energy can't sneak between the vias and come radiating out the side of the board. But we do not need to pass EMC testing. We do not need to do anything that I've done. There's a lot of space over here. I wonder if we should do some decorations. feel like there's a switch missing. On the other computer, the one that I don't have cammed up, I have a touch screen. And this would be a good time for it. Okay, so you get the idea. It is rare that you have these fields of unused space in your board because it's not doing anything electrically. You're paying for it, so why have it? And the answer is you wouldn't. You would shrink your board so that you can fit more boards per panel and then have an overall lower cost to your design. Are those going to be clear? That's going to be close. Since I put them kind of randomly around the board, I don't know which ones got captured in that copy operation and not. All right, so what we're looking at is cleaning up all of our silk screen, right? These things should be very easy to relate to where they go. So that somebody doing inspection, if there's a part missing, they know what that part is without referencing the schematic. You can't have silk on copper pads. You can't have silk on holes. Your fabricator will delete it. Looks like that one goes with that one. I think I'm going to have to put these things in a group. Okay. Where does this one belong? I might actually do this on the bigger computer where I've got higher contrast, since this little screen I'm working on is annoying me. But you basically get the idea. Let me turn off the silk and show you what I've done. Now's a good time to summarize. Don't need dimensions, don't need the silk. I just want top and bottom layers. Underneath every wire, every trace, there's copper. Doesn't matter if we're looking at the top of the board or the bottom of the board. Everywhere there's copper, right? Let's look in a spot, right? These traces, copper, pure uninterrupted copper, copper everywhere. All these traces, copper. Underneath these antennas, copper. Right, we'll tie all of this together. All of these traces, this big, multi-lane highway of traces. Copper. Get it? Copper, 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 copper. And nowhere is that path broken, is that return path broken, any place that it is. Like here, you know, if we came down these traces, this differential pair, and we came over here, yeah, it's broken. The doesn't matter in this case because it's going to be in the same dielectric. Who cares? But the way that we bridged that was with vias. So the vias, any energy that's going to be between the layers of the board, between this differential pair and the bottom, or this differential pair and the top copper, we gave it a path, a multi-via path to get back. Does it need it? I doubt it needs it, but it's there if it wants it. We don't know. We did teardrops or keyholes on our vias so that if the drill wanders, it's not going to wander out of the hole. Do we need it? Not on this design, but it's there for us if we do. I think I am going to shift this up ever so slightly and see if that gives me a little copper on the bottom. It does. All right, so still some work to do, but there is a 2-layer design. Feel like there's a switch missing. Like this whole area where I'm like, ooh, there should be more stuff. Where did that switch go? 1, 2, 3, 4, 5, 6, 7, 8. Oh, man. How did we delete a switch? All right. Here's how you catch that error. I don't even know how we did that. I'm going to get all that crap out of the way. I am going to renew from schematic. Yeah, keep the PCB layout settings. That's fine. Hierarchy. Must have been when I was ripping stuff up and putting it back down. That is unfortunate. Okay. All right, it is time to do a little bit of error checking and get this thing ready to ship off. We're going to split error checking into a few different aspects. The first is going to be what I'm going to show you now. This is stuff you need to take care of before you send it to anybody to take a look at. And then you're going to send it to some peers who are going to try to identify some mistakes. After that, you're going to send it to me, and I'm going to run it through a DFM at Royal Circuits for you. That'll let us know if your board's manufacturable or if there's any issues. And then it should be safe to send off to your fab house. So we're going to try to do a little bit of error checking for you, but really the onus is going to be on you. Nobody's going to know your board as well as you know your board. So let's get going. Let's get this thing ready. Also, I got rid of that little confounded monitor, so I'm working off the laptop screen, but it's a little far away. I got a new one coming. It'll be here soon. All right. So the first thing I want to do is probably take a look at the silk screen and get that cleaned up. I'm looking to have everything relatively ordered so that it's easy to populate the board and easy to error check. You can have things going at angles. I don't tend to like when they do, so I'm looking that everything starts and stops in roughly the same location. And then if I need to move anything around, There we go. You don't want any silk on pads. So like here where it looks like it's overlapping, it's two different layers. It's fine. No silk on pads, no silk on holes. That'll get cut off. So R401, which by the way is way over there, that thing needs to get moved anyway. But see how I've got the thing reversed? That needs to get fixed. Rotary encoder, 401. I also added a couple dimensions. So these are for later. I'm going to do something called a paper doll. I'm going to print this thing out. I'm going to put my parts on it to see if everything fits the way that I think it should. But I need to have it print to scale for that to work. So these things will let me calibrate my printer later. So let's save that. Let's go back to verification and check design rules. Okay, it's still mad about these things being a little too close together, but remember, the assembly houses don't, I mean, I don't think any assembly house cares if you're at 6 mil spacing. Most don't care if you're below 5. Royal is fine at 2.5 or even 3, so who cares on that? And then this is mad about the uncoupled length, which is something I don't want to talk about right now because of the incident. No, it's fine. It doesn't matter. Okay, so those are done. We can also go back and check net connectivity to see if there's any short circuits that I might have missed. Oh, ground is broken. 4 areas. No. So it's highlighting all the ground connections for me. And it's telling me what areas that they are disconnected in. Area 2, R7042. So let's go hunting. And why does it think that that ground is broken? It's connected with a thermal. Let's update all copper pores. And let's do that again. So check net connectivity. Interesting, interesting. Oh, you know what it is? Oh, silly me. It's in fact not connected. Clever, clever. Thank you, DipTrace. Thank you. You're absolutely right. And I'm wrong. So wrong. So very, very wrong. So I'm going to add some connectors here, and I am going to drop them down and put them on the same net. And we're going to watch one of those disappear. So let's see if R7042 is still there. 3 areas. So we've got some of these ground pores that are not connected to other things. We've missed a couple. You guys should have told me. You really should have told me. So R705, pin 1. That must be this guy. He ain't connected to nothing. Nothing, I say. Object. Update all ground pores. Oh no. And you know something? I'm going to dethermal that one. Direct connection current pad. There we go. All right, verification. Check net connectivity again. 2 areas. U2013. This is it. Boy, I tell you, the trouble that you guys were about to allow to happen, I can't even think right now. I mean, the thought of it, it just makes me too sad. So I need to connect ground to this, to that, to that. I might need to give those things a tiny little nudge. Up. Okay, up, whoop, cancel. Update all copper pores. Go back to verification. Check net connectivity. No errors found. They're all connected now. Whoop, I don't want that. Verification. Check design rules again. Now that I've added those in, same 2 problems, and I'm going to continue to ignore those. And then I'm going to compare this to schematic. I think 1 had some corrections. I think 1.02, I fixed some net names, but that's going to be different. So, yep, it was 1.012. Okay, so under all my verification, check design rules. We passed, except for the ones that I'm choosing to ignore. Okay? Under check net connectivity, is everything connected the way that I think it's connected? Do I have any disconnected nets? No. Do I have any shorted nets? No. That's good. And then compared to schematic, no errors have been discovered when comparing to reference schematic. We're golden. Okay, it's now ready for the paper tiger test or the paper doll test. So now I could go and calibrate my printer, figure out, you know, I would have to print one of these out and sit there with a ruler and figure out if it is exactly as big as I think it is. And then, you know, adjust it, print it out, see what it looks like. No problem. At that point, we're ready to export to a fab house or a Gerber viewer. So, file, export. ODB++, great format. You can also export to Gerbers. Most fab houses take, you know, whatever you can give them. But the ODB++, it's going to have all the Gerber information and more. And I'm going to go ahead and compress it. Give me one big fat zip file. And I'll just drop it on the desktop for now. Okay. So there's that. That is something that you can then give to your you'll give it to me for the DFM check. All right. So we ran all of the software's internal checks and passed them or approved, disapproved of the issue. We're going to print this out at scale and then take our parts and actually physically set them on the LAN patterns that we created to see if it's reasonable. And then we're going to export the Gerber files so I can do a DFM for you. And then finally, we're going to share these for peer review, and you're going to see if you can't help out your fellow participant. See what there is. Maybe there's an error, maybe there's not. I don't know. But wait, there's more. There's something else you can do. Sometimes you catch errors with this, sometimes you don't. But if you do a 3D visualization, this is going to be a little tough because it looks like I don't have all of the files that I need on this laptop. Will it let me? Oh, that's a shame. Okay, well. Anyhow, I'll have to get that fixed, but I have that going on my desktop. But anyways, it gives you a board, and you can look around, and if you have your 3D files loaded, you can take a look, and sometimes you see things that you didn't see before. Like, look here. Look at R705. Did you notice that? I didn't notice that, but that's something that we're going to want to fix before I send this off and ask anybody else to look at it. You can see the jumper wires. See how that's a jumper on top? That needs to be a jumper on bottom. Most of my jumper wires need to be jumpers on bottoms. So it lets you go through. This is the top. This is the bottom. So it lets you go through and catch those mistakes that you might not have caught before. Here's another jumper wire problem next to R408. See how I have the jumper wire assembled to a via? Ain't nobody got time for that. So now I have some things to look at, some things to fix. All of my jumper wires need to have solid copper underneath them for this design. So the 3D view has all sorts of use, and if I loaded up my 3D files, you can see even more of what's going on. But I don't have them, just the default ones that come with dip trace. Bummer. Okay. Anyhow, that's it for this. Have fun laying out your files, folks. I'll see you on the other side.